Hello and welcome to another episode of Spiritually Incorrect. On this episode, we have Are You Made of Nothing? Telekinesis on the Andromeda Galaxy, and Paul Rudd, the Infinite Being. I'm your host, Seth Hart. Joined with me is Jonathan Lionheart.
Hey!
John, we're talking a lot about Marvel stuff today. Quantum physics, and 90% of the people I know only know about quantum physics from these movies.
Yeah. Well, I was going to start off with a quantum physics joke, but as soon as I tried to measure how funny it was, it collapsed into disappointment. So
That is the most niche, nerdy joke I've ever heard. That's an accomplishment, because I've heard a few from you.
Get on the wave function, man. You got to get on the same valence ring as me.
I got to get at the quantum level, man. All the cool stuff, if you believe these movies, all the cool stuff is happening down there. Although I haven't even seen any of them recently.
Go ahead.
I'm part of the group that's just boycotting everything since Endgame.
Oh, see, I get that the consistency of the quality is not there, but post Endgame, we've had the third Spider-Man, we've had Deadpool and Wolverine. Like, there's been some of the highlights of the Marvel Cinematic Universe. Consistency is down, but I haven't given up faith in the whole thing.
I applaud your faith.
When Tobey Maguire stepped out of the portal thing, I absolutely lost it in the IMAX opening night. It was one of the best cinematic moments I've ever experienced as a human being.
It was pretty great. I did see that one. I'll admit that one was good. I left though feeling like it was like empty calories, because I still was like, where is this universe going? I don't know. It felt like
it's going directly to my heart.
Oh gosh.
It
can stay there. It can stay there. Some of the other ones, I have seen a couple others, and it's just, you're right. The quality, it just doesn't quite ring like it used to, I suppose. Although I do need to see the new Deadpool. I couldn't think of the name of it. I need to see the new Deadpool.
You ain't seen Deadpool 3? Oh, it's so good.
Oh, I know. Okay. I'm really far behind on movies, just generally. It's funny that you know this. After you have kids, going to see the movies is so much more of a hassle.
Maybe for other people, but I have my priorities straight, Seth. So
we did go to see Godzilla -1 in theaters whenever Shepard, right before he was born, and every time Godzilla roared, he jumped in. He jumped in the womb, and my wife's over there is like, he's getting really scared.
When our kids were first born, I think I was still trying to imagine my life as a bachelor, and I was still trying to go to movies. So I would still go to movies. I would just fall asleep for them. So I have fallen asleep through both of the last two King Kong movies. I have no idea what happened. I keep trying to see these King Kong movies, and I can't get through them.
Like the Godzilla Kong movies?
Yeah, I fall asleep in a Godzilla Kong theater. Like, probably very bombastic and loud, but I don't care. I'm too tired.
Speaking of empty calories of movies, I mean, yeah. I say that, and I am like, I grew up on the Godzilla movies, so I'm all for them. Well, none of this has anything to do with what we're talking about, John. What are we actually talking about?
I love it. Screw getting a natural transition. Just do a non-transition transition to the topic.
What are we going to do? Just keep talking until something natural pops up? We'd have like a 20-minute long intro.
That's what we usually do. Well, today we have Allan Furic, who's a doctoral candidate at the University of Edinburgh. We met him at AAR last year at the American Academy of Religion. His supervisor, Bethany Solerator, introduced him to us and said, you have to have this guy onto your show to talk about God and quantum mechanics. And we said, okay, Bethany, we'll do what you say. Because Bethany's awesome. She's been on the show before. We did an episode with her on climate change and religion. So check that out.
Yep.
Yeah. Environmentalism. And so check that out. He also, Allan Furic also works under Mark Harris at Oxford. And so he's got two great supervisors for that. And he's doing his PhD specifically, I believe, on quantum physics and Buddhism. And he's one of the only people in the world that's looking at that subject at this academic level. So we're privileged to have him on.
Yeah. And this is going right up our alley, because I love the science and religion stuff. I did my PhD on that. John and I have co-taught a class on Eastern philosophy. Go check out our Patreon. $5 a month, you get full access to that. And so it's just something that it seemed like a natural fit, beginning to ask the question. Yeah, we normally do Christian theology stuff, but this seemed like a fun little side tangent. We also had a whole episode with Tyler McNabb where we asked him the question, can a Buddhist also be a Christian? And he said, yeah, I think they can be. They can't be a Catholic Christian because Tyler's Catholic, but they can be because the claims of Buddhism don't really align with what we think of another religion. And I'm not advocating for Buddhism here. That's not my point. My point is to say that what you're about to hear, like, understand that it's not going to be, don't have your defenses up immediately. Begin to think and see it from the lens of how can we actually maybe take some of this and appropriate it and use it in Christian theology.
Satan is crouching at the door, and Seth wants you to leave it cracked open. Just see what happens. You know, just
give me a break.
Just leave it open a little. Leave your hearts open. See what Satan does with that.
You're the one dressed in a red jacket right now. You do look a little satanic, I'm not going to lie.
Well, thank you so much, Allan, for being here with us today. Your research is on quantum mechanics and religion. But before we get to the quantum world, can you maybe give us a sense of the world it replaced? What was kind of our pre-quantum picture of the world?
Yeah, of course. Yeah, thanks for the question, Jonathan. So before the advent of the 20th century, so the very beginning of the 20th century, the main picture that physicists had was that of classical physics, which emerged in the 16th, 17th century with people like Galileo, Copernicus, and later on Newton. And this was kind of the clockwork picture of the universe, something very smooth where everything was determined, and where if we follow Laplace's demon, if an agent with superpower abilities were to know exactly all the characteristics of all components of the universe, he could predict their entire future. And so this was basically the model that physicists were working with, until some people discovered new ways of doing physics, notably Einstein and the fathers of quantum theory in the 1910, 1920s.
And what kind of shift happened with that, especially in quantum mechanics? How did that disrupt this picture of a sort of deterministic universe?
So it's commonly referred to as, there was that famous physicist Lord Kelvin, who used to say that basically physics was done by the end of the 19th century, besides two small issues in the picture: black body radiation and the Michelson-Morley experiment, right? So the first one, black body, it's a hypothetical body in physics that emits radiation, but discontinuously. And this is something that classical physics cannot explain. The second one, the Michelson-Morley experiment, tried to explain that light waves were carried out in space through a luminiferous ether, some sort of substance. But the experiment failed, as is mostly known in the scientific community. Those went on to develop, respectively, quantum mechanics and relativity theory, the special relativity theory, and then general.
So what new ways of resolving black body radiation and the Michelson-Morley experiment came about? Like what were the experiments or observations that kind of said, oh, we need to switch our whole model of physics? Like what experiments did quantum mechanics get birthed by?
So it started with Max Planck, famous figure in the physics world in between the 19th and the early 20th century, who has given the term quantum to quantum mechanics. So quantum in Latin means indivisible, something that you cannot cut off in different parts, right? And that was something that he used to explain, that actually energy was emitted in a discontinuous matter instead of continuously, like classical physics predicted. And they didn't really understand what was going on. Even Planck himself thought that he was going mad, because he thought that there was some problem in his equations. But as a matter of fact, there wasn't. And later on, in the 1920s, the main developments mathematically of quantum physics emerged with people like Werner Heisenberg, Niels Bohr, Wolfgang Pauli, and others. Erwin Schrödinger as well is a famous one.
And what were their discoveries? We commonly hear that the quantum world is, very strange and tough to explain with common sense. Can you give us some examples of that?
Yeah, so I guess the most famous example would be the wave particle duality. So quantum physics describes physical systems at the lower scales of matter, right? So atoms, subatomic particles, some molecules, and explain how they move around, right? And how the forces imposed onto them play in that big game. And what was basically explained by those early physicists of the 20th century is that until we make an actual measurement, an observation, the state of a system is undetermined. It can exist in multiple dispositions. So a particle, for example, like take an electron, could be in different places throughout space until we actually make a measurement that gives us probabilities to have it in a specific area. Let's say, I don't know, in an apparatus in the lab or in this table that is in front of me, instead of another galaxy, for example.
So a particle can be in multiple places at once until someone measures it?
Yeah. So the problem is that quantum mechanics really gets to the heart of our notion of reality, what it means for our physical theories to describe the world objectively that lies out there. And I think that's the major element philosophically that quantum mechanics is challenging, which physicists are not devoting enough attention these days, actually ever since the 1950s. So you have that element in the quantum mathematics. It's called a wave function. In the standard formalism, so the formalism that most physicists would rely on nowadays, it's considered as an epistemic tool to make probabilities, to predict specific outcome in experiments. So it's something that is elementary in the mathematics, that was introduced by Erwin Schrödinger in 1926, and that is very easy to use in the calculations. The problem is that that wave function describes those different positions in space of the particle, right? And so until we make that measurement, we have no way of saying where the particle actually is, if it is somewhere.
Okay, so things aren't located in one particular place until we stumble upon them is kind of the idea. And so all of our intuitive senses of reality at the macro level just aren't applying at the micro level. Reality isn't playing by our laws, basically. Is kind of...
That's what it seems, yes, indeed. Although I would caution in not reading too much into quantum physics because it is very fuzzy. It is completely granular. It is something that is in opposition to our common intuitions about how the world runs, right? But it is a very established science at the basis of most of our modern technologies, and this is very important. It's actually the most successful science of the entire history of humankind. I can't hear you, Jonathan.
What kind of technological advancements has quantum mechanics led to? I think for a lot of people, they just think of the quantum and they think of this realm that's very abstract and distant. But what very tangible things has it changed, technologically speaking?
Many things, actually. Take a laser, for example, right? A laser in a lab, or even you don't even have to have a lab. Like if you buy those like pointer lasers that you have in how do you call those? When you go to parties and stuff, you can buy those mini lasers you can point in the wall, on things with very low frequency. Those rely on those 1, 2, 3 rely on quantum technology to work. They weren't possible before the advent of quantum mechanics. We also have many developments in research nowadays. Quantum computing is one of them, developing new quantum computers that have a capacity to compute that is much higher than regular computers we use every day. We have quantum biology as well. Other things, I did make some notes. Transistors, for example, in computers as well, those rely on quantum technology. And we have many more. GPS is another one. And those technologies really are dependent upon the development of quantum mechanics, how it was developed ever since the 1920s.
So let's get into kind of the fun part of all of this, which is there's many different ways that I've heard to make sense of this, many different interpretations of quantum mechanics. What are some of these interpretations?
Very interesting question. So what I would like to remind people that are listening to us first is that there is, like, the quantum science works perfectly when it comes to, as I stated, like, developing new technologies. It's very successful, but we don't really understand what it is saying to us about reality, if it is saying something. Why? Because of that state, that transition from the mathematical state to probabilities, at which point we measure the different outcomes in the lab. And so to try to make a sense of that world, physicists and the quantum founders themselves, first and foremost, try to develop a way to interpret the theory, what was going on. The first interpretation is called Copenhagen. It takes its name after Niels Bohr, who had an institute in Copenhagen. And it's considered still as kind of the orthodox interpretation followed by most people nowadays, although it is not a unified perception of the quantum world. So if you take, for example, the version of Copenhagen of Bohr or the version of Copenhagen from Heisenberg, those are slightly different, right? So Bohr would say that you actually need both the wave and the particle pictures to make sense of the quantum world. Heisenberg, on the other hand, would have stated in Physics and Philosophy, his main popular book, that quantum mechanics is at the crossroads of both ontological and epistemological aspects regarding reality. This was the first that emerged. The second one, which is one I'm working on in my research, is called the pilot wave interpretation, developed by a physicist called David Bohm in 1951. And Bohm, instead of stating that there was that wave-particle duality, went on to say that no, actually we have two different phenomena, a wave on the one hand and a particle on the other, and the wave guides the particles along defined trajectories. And so Bohm basically found a way to eschew the problem of wave-particle dualism and the so-called collapse of the wave function, by positing that particles always had a determined position in space, but were guided by those waves.
And what about the many worlds interpretation that you see thrown out all the time? What is that one?
This one is quite popular, especially in Marvel movies, or even with physicists who have a philosophically inclined mindset, I would say. So the many worlds emerged out of the work of Hugh Everett III in the 1950s as well, although it was really popularized back in the 1990s. Actually, the term many worlds wasn't introduced by Everett, but by another physicist in the 1990s, whom I forgot the name. So the many worlds states that so when you have different possibilities for measuring specific properties of quantum phenomena, like, for example, the spin, which is the rotation of a particle, its position or its quantity of movement, what physicists call momentum, or its time or energy, you have one particular quantity that is realized instead of the other. So if you have, for example, spin up, you know that the other particle is going to go spin down. If you measure the position, you know that you cannot measure the momentum at the same time. I'm going really fast on this, but it's rather complex. Everett posited that actually, no, what we have is that all possibilities are realized all the time. What happens is that when you have one, let's say I'm measuring the position of one electron, and so the momentum, the speed, is going to be realized in another universe that is, if you can say so, created for that specific purpose. So all quantum possibilities exist all at once when quantum choices are being made all the time. And this is a rather outlandish, I would say, interpretation, because it seems that there is an infinite number of universes with an infinite number of people making quantum choices all the time, which is rather far-fetched when you think about it.
So every possible choice or every possibility ever, there's a universe where that happens.
Theoretically, yes. From the perspective of quantum mechanics and Everett's interpretation, is termed actually, like in the scientific jargon, pure wave mechanics. So it's really like based on the mathematical formalism, which it takes literally, right? If it's like applying the math directly to the world. And I think personally, but that's my opinion as a scholar, I think that's where you realize that, no, I'm not sure it works. Mathematically, it is rather elegant and simplistic. It respects Occam's razor. From a metaphysical perspective, it's completely mind-boggling.
So you're super skeptical of that one, and you are working on the Bohmian pilot wave interpretation, where there's this pilot wave that guides the particle. Is there evidence for yours over, say, the Copenhagen or the many worlds?
So, as of yet, there is no evidence as to which interpretation is the right one. Right? If you take the book by a philosopher of physics called Jeffrey Barrett from 2019, The Conceptual Foundations of Quantum Mechanics, he said that actually, at the end of the day, it's a matter of personal choice, which one we go for. I think that we ought to find a way, like, to interpret the quantum world at some point in the future evolution of physics. For now, we don't have that answer. So all choices are on the table. Some are obviously preferred by physicists, more to their taste, I guess. Others have been a bit dismissed, like Bohm's interpretation was completely dismissed when it was first developed by Bohm in the 1950s, and was only later on taken upon by some people in the 1980s.
So to help me and perhaps our audience as well try to get a grasp on these, Heisenberg's interpretation sort of seems to be that our usual rational way of seeing reality just isn't correct. It's more mysterious than that. There's not this cause and effect relation where the outcome is going to be deterministically set by its prior state. You only have probability, not deterministic, rigid states prior to observation. But these other two views, the Bohmian seems like an attempt to say, no, cause and effect still work. There's some sort of underlying causality that explains why, when the wave function collapsed, it went here rather than there. It's not just chance and probability. There actually is something there. So it's an attempt to say, we might not be able to observe what is sort of determining these outcomes, but there is something there. And then the many worlds theory also seems to be an attempt to maintain reason in a sense. Or am I wrong about that? Where it's saying, it's not just probability and chance. All of these possibilities are actualized. And so therefore, in order to maintain reason, we have to expand and say they're just actualized in worlds that aren't our own. And so would the many worlds and the Bohmian both be an attempt to maintain causality, whereas Heisenberg just sort of says, no, we don't have to keep causality. We can get rid of it.
So I would caution against dismissing causality entirely. This is definitely a problem, especially when you consider the phenomenon known as entanglement, right? So when particles are related together, their states are related together, and when you make a measurement on one of them, that's going to affect the other one, even if both are located in different parts of the universe, be them different galaxies, right? Which apparently violates what we call the principle of locality, so that when signals need to be transferred from one point to another throughout space, to ensure that it doesn't go faster than the speed of light. In Bohm's model, it was accused of effectively rekindling determinism in physics by most of its detractors back in the 1950s, 60s. But as a matter of fact, in the very mathematics of the Bohmian interpretation, there is an element which we call the quantum potential that ensures that all the connections between all particles in the universe are non-local. So that is the term called non-locality, which is the main interpretation for entanglement. So when you have two systems that interact, let's say you have one on Earth, right? The other one is located in Alpha Centauri, in another galaxy. When you make a measurement, spin up on the electron, you know from the quantum math that you're going to get spin down on the other. That's unavoidable, right? So apparently you have that action at a distance that Einstein could never accept, the spooky action at a distance. But as a matter of fact, there is a phenomenon called non-locality here. So you don't have a transmission of signal between the 2 points, A and B, but you have something non-local, something that is other, that we don't really explain properly, I think. Most physicists don't really know what it is. We know how to transcribe it mathematically, but so far as to say metaphysically what it is, that's another question. In Bohm's model, non-locality is fundamental. So it really questions causality as well.
So what you're saying then, if I can say this back to you and let me know if I'm on the correct line of reasoning here, I can take a particle and I observe it and it starts spinning one direction.
Yeah.
Then I know that if there's another particle, however far away, 100 million light years away, it will start spinning in the opposite direction immediately, instantaneously.
So theoretically, yes. It's been that phenomenon, entanglement, has been confirmed experimentally several times in the 1970s, 80s, 90s, and even like more recently. So there's no questioning as to whether entanglement is a real physical phenomenon.
That's interesting, because whenever I start to make an argument, somewhere off in the distance, Seth starts to make the exact opposite argument to counter it. And
I am not entangled to you in any way. If there's any physical way to get that unentangled, let me know, Allan. So basically, this is just saying that everyone's kind of weirdly connected then, right? If you're saying that for Bohm, every particle is entangled, that means it's like what I'm doing right now is affecting things in the Andromeda Galaxy then. Is that right?
Theoretically, yes. And if you go far back to the early universe, so close to the time of the Big Bang, right? The original time of when the universe emerged, came into existence, because of the conditions of the early universe, everything was entangled. And theoretically, it's still the case. One thing that I would caution with here is to make a philosophical reading of interconnectedness, which is my whole PhD, which would apply to everything in the universe, even at the macroscopic scale. Why? Because evidently, I don't feel a connection with Alpha Centauri or another galaxy, right? And it doesn't seem that I'm being affected by a measurement that could have been conducted at such a far distance. Why that is? Well, one possibility that has been put forth by physicists is called decoherence. So when you have complex systems like a human body, a brain, a planet, you have way too many variables that play into the picture, different quantities that interact with each other, so that in effect, it collapses itself. And so you end up with only one possibility instead of the superposition of different possibilities. This is
sorry, go ahead.
Go on.
Oh, so basically what's happening then is I might be affecting something in the Andromeda Galaxy, but so is everything else around it. And so in some sense, it just kind of all cancels itself out.
That's one interpretation that has been developed. Although decoherence has some experimental confirmation that goes for it as well.
So if we're, I think I know where Seth was going here, but so if everything is entangled, I think a lot of people use that in spirituality to kind of argue all things are connected. And so we and the universe are one, and God and us and all things are one, and that locality and difference is an illusion. Can you talk about kind of how that plays out in modern spirituality?
Yeah, translate this to the self-help book that I read last night.
Yeah, because I hear this. I hear people say quantum entanglement, therefore we are all one. I see that all the time in modern spiritual books.
This is, I think, a major problem when you use specific concepts that apply in specific, specific concepts that apply in specific contexts. In that case, scientific contexts, and use them in the general parlance of our everyday life, right? So to say that we're all entangled, to an extent, is a true proposition. Because we're all related together as a community, as a society of human beings living on Earth. There's no problem here. To say that we're quantum entangled, no. I don't think we should go that far because of decoherence, right? And there is still the problem of how do you entangle many particles throughout the whole universe, and given how many particles exist, right? It's mind-boggling, the number. I'm not sure you could maintain that state of entanglement indefinitely without having some form of decoherence. So I think it's a problem to read too much into quantum physics to back up like theological claims.
Well, let me play Oprah's advocate here. So what if someone were to say, okay, I don't think quantum entanglement proves that we're all one despite our differences of country and geography and race and religion. But what it does show is that two things can be connected even if they seemingly look different and are at a distance. And so that doesn't prove my whole worldview, but it does show that the seeming duality of our world isn't what it seems, and that perhaps there is some cosmic unity that we might not have full scientific proof for, but we have these precedents and little hints of it, such as what we find in Entanglement, that show perhaps all things are united in a deeper way. What might you say to someone trying to do that?
So this is a very interesting question. Thank you for asking it, because this is something I'm investigating in my research, albeit briefly, in relation to Buddhism specifically, right? So in Buddhism, and you could extend that to Hinduism, so mystical traditions to an extent, those that incorporate some form of meditative insights into their practice. Modern yoga would be one of them. There is this idea, specifically in Buddhism, that we're all empty of intrinsic existence and property. Why? Why that is? Because things cannot be engendered ex nihilo, separated from the chain of causality. This is a major concern in the history of Buddhist philosophy. Why? Because in so doing, they could explain where the suffering comes from. That is attachment to a seeming permanence of things, which it seems is an illusion. And so this concept is called interdependence or dependent origination in Sanskrit, pratitya samutpada. It's really important, and I think it explains in a very interesting way how things can be related. To go more deeper into your question, I think that because the meditative insight can be one that is of other types of conscious states than we ordinarily experience in the everyday world. So, like beta waves that enable cognition and so on and so forth in the brain. It seemingly allows to have experiences of connectedness, of oneness with reality that we are otherwise completely foreign to. And that's where you could draw an analogy with quantum mechanics, so far as stating that this is the same thing that both worlds are explaining. I don't think you could go that far. Why? Because if you say that there is such convergence, you start from 2 points and you converge on a similar understanding of reality, then it means that somehow both are capable of accessing that quantum non-local ground of reality. And I'm not sure that Buddhist practitioners are actually doing that in meditation, although I could be wrong.
So, yeah, I mean, basically you're leaving open the possibility that this experience
Yes.
of oneness, this ego death, I have a psychiatrist friend who talks about this all the time, that meditation or these drug experiences can induce, is it corresponds to a view of reality that Bohmian mechanics hints at, but you're not setting your foot down and saying they are experience quantum entanglement.
No, I think that's this. I think I would make that a necessary condition to claim that there is convergence between the two. Right.
And something I'm curious about, did Bohm himself ever think about this sort of stuff? Was he into spirituality?
As a matter of fact, he was, yes. Well, the extent to which he was actually a believer in something, I don't know exactly. But he was definitely in conversation with people like notably Jiddu Krishnamurti, who was the head of the Theosophical Society. So a major movement that tried to expand Hinduism in the Western world back in the 19th, early 20th century. And Bohm was in conversation with Jiddu Krishnamurti in Cambridge back in the 70s, 80s, and really tried to make sense of the world in which he evolved, as well as Krishnamurti. And back then, in the 1980s, Bohm had developed a new ontological model that he superimposed onto his pilot wave interpretation, which is called the implicate order. So in the implicate order, basically everything is enfolded on itself. So it's like thinking that one atom would contain, as an information potential, the entire universe. Right? It's the idea the one contains the many reflect the one. You have something quite similar in Western Hermetic philosophy from the Middle Ages.
As above, so below.
Indeed, yeah.
So basically, it's this idea. So there are like these like holograms where if you split it apart, and there's still enough information to reconstruct the whole, even from a tiny little part. And he's basically saying that the entire universe is like that, this implicate order, that from an atom there's somehow enough information to reconstruct the universe.
Yeah. So Bohm used the hologram as an example to make sense, to illustrate the implicate order, right? To make it more intelligible. But he didn't say that the universe was an actual hologram. Why? Because a hologram is developed out of a three-dimensional apparatus in a lab, which is the first concern. That the implicate order is not. And second, it's the reverse process. So in the hologram, you have higher dimensional picture, like three-dimensional, of an apple, let's say, that is containing a lower dimensional signal on a surface plate that you can illuminate to recreate the picture. In the implicate order, it's the other way around. So the implicate order is actually multidimensional because of the wave function. Because the wave function in the scientific jargon evolves in a configuration space that contains all the possible coordinates for the particles in the universe. Given that each particle evolves in a three-dimensional world, so three coordinates in space-time, you add that up for the enormous amounts of particles you have. So you end up with a 3n multidimensional reality. And that's what the implicate order is, according to Bohm.
If I can return then, going from the implicate order to Buddhism and this idea of emptiness, can you give us a little bit of the history of this idea of emptiness? That, I thought quantum physics was hard. This just seems just as difficult. So can you explain that a little bit more of the history and like why they arrived at this idea?
Yeah, of course. So Buddhism, as you are all aware, comes back to the original Buddha, Siddhartha Gautama, who was a historical figure, or so we think, who roughly existed in northern India in 500 BCE, before Christ, or the time that we apply in that specific part of the world. And the Buddha was famously concerned with suffering. Why there is suffering in the world. This is the first noble truth of Buddhism, that there is suffering. And he found a way to alleviate that suffering, to understand its cause, second truth, where it comes from. And the way to go towards that is to reach what he calls nirvana, which is basically disentangling ourselves from that suffering through the Noble Eightfold Path. And so here you have the essence of Buddhism, basically, without reducing the entire tradition just to that. And the emptiness aspect, as I explained earlier, comes to the picture in explaining that, in fact, when we see permanence, this is a misleading picture of the world that we have, because things are constantly engendered by a cause and are the cause of an effect in the infinite chain of causality, which also means that in the Buddhist cosmology, the universe is cyclical. It runs on itself. Right? So if you portray that with theories of the Big Bang, that might be a problem. But anyways, emptiness really means that things are dependently originated. They cannot be separated from each other. That's the meaning. Then you had a major philosopher, 2nd century AD, or CE in the international system, by the name of Nagarjuna, who wrote a treatise in which he really explained that substantial element of emptiness and why it goes at the heart of the whole philosophy. And what Nagarjuna did in a very complex, logical, analytical treatise was to desubstantialize reality as to what it is not. In order really to get to the heart of what it might be. And what it is emptiness. If that makes sense, because I know it's a very abstruse concept.
So kind of the idea then that Nagarjuna is playing with is that my emptiness, it's not that I'm nothing, it's that everything that I have is derived from other things in that way. So there's nothing in me that I exclusively have.
Yeah.
Everything is sort of interconnected. And so the emptiness is maybe this idea that I possess my own characteristics that don't need to be in any way referenced to something else out there in the world. Everything is connected in that way. Is that right?
Go ahead.
Sorry.
To an extent, yeah. Because the purpose was really to try to explain, to try to explicate that the origin of suffering and why we cling to erroneous perception of permanence in the world. So this is really the meaning of emptiness. Although later on, especially if you follow Chinese and Japanese Buddhism, it was expressed differently, obviously because it was a different context.
And just to clarify how that's connected to quantum mechanics per se, is part of it that no quantum event occurs in isolation. It's only when it's measured or interacted with that the wave function collapses into a specific thing. And prior to that, it doesn't have a solid specific position, and it could be seen almost as nothing or everything in a way.
Well, I mean, that's what apparently the math tells us, if you can say that the math tells us anything. One course of action that has been endorsed by some physicists and some philosophers of physics is to say that actually maybe the consciousness causes the collapse of the wave function. It's an idealistic interpretation, thinking that we are the product of our reality. I wouldn't go that far, for the simple reason that you don't actually need a human brain to perform an experiment in a quantum lab. So for me, that doesn't make much sense to think that the consciousness of the human person is necessary to collapse the state of a quantum system. And then because if you rely on that interpretation, you end up in really difficult, murky waters, notably the fact that how do you explain the existence of the universe in a deterministic state before the advent of the human race?
Well, wouldn't that be where God traditionally is thought to have come in? Because God is the eternal absolute observer. And so you don't need human observers in order for events to occur.
From a theological perspective, I guess that could be possible. And you could even make the case that, in the traditional Imago Dei idea, so being made in the image of God, we kind of are the co-creators of the universe from a quantum perspective by collapsing the state function in light of the mind of God. Personally, I wouldn't go that far, but
Can I ask a kind of a side question on that?
Yeah.
How small do things have to be in this quantum state of potentiality?
I don't know the exact order of magnitude. It's very low scale, right? Usually when we get to the scale of complex molecules, it seems that the quantum effect cease to be valid. I think the highest, like the biggest scale we've come to in measuring quantum phenomena was, I think it was 2 or 3 years ago, when they put that little creature, a tardigrade, which is apparently thought to be one of the most resistant creatures on the planet. They managed to put that tardigrade in a state of entanglement by freezing it near to absolute zero. And it survived. So I don't know if the literature nowadays backs it up and say that effectively, it wasn't a state of entanglement, but back like 2 or 3 years ago, it was a major breakthrough in empirical physics.
So just kind of a follow-up to that then. At some point, near the Big Bang, the universe was theoretically that small, right?
Yeah, yeah.
And so at some point there would have been an observation that would have collapsed the wave function of the early universe, correct? It's a curiosity that occurred to me a couple years ago, and I've always wanted to ask an expert. And
well, I take that comment of yours to remind you that I'm no physicist, right? So.
Sorry, I ask you. You're the closest thing I have, man. I'm sorry.
Well, I think your point was that it's not an observation; it's an interaction, and an interaction could happen at the Big Bang without it needing to be God, because it doesn't need to be a conscious observer.
Well, I mean, yeah.
When we talk about observation in physics, and it's valid for classical physics as well, by observation we mean measurement, right? It doesn't mean observing through our senses. And that's where people are misled, because they then again take quantum physics out of its context, the mathematical equations and experiments in the lab, to apply it to our everyday world. And I'm not sure that it works that way.
Can I ask a follow-up point, which is connected with the Big Bang? Often you hear sort of religious people try to say, what caused the universe? Well, you need, the Big Bang shows the universe was caused, so it began to exist. And it can't just keep going back and back and back in an infinite regress. There has to be a timeless, eternal rock bottom that creates. And the universe began to exist, so it must have a cause of its existence. That cause must be God. Obviously, that's the traditional cosmological argument. But a response I've heard some people give to that is that quantum mechanics shows that events can occur without a deterministic cause. And so therefore, perhaps the universe didn't need a prior cause. It could just sort of spring into existence without that prior deterministic source. Because we don't need a deterministic cause of the universe. The quantum void can do that for us without need of a proper cause like God. What might you say to that sort of argument?
I mean, I know it is one of the speculations of contemporary quantum cosmology. The quantum vacuum, the quantum void that pre-existed the universe, well, before the Big Bang. As to whether it solves the problem of a creator deity, whatever that may be, I'm not exactly sure, because we still have the main problem that we can't experiment on that early, at the very time T0 of the Big Bang, or even before that. Why? Because we're limited by Planck's time, which is a constant 10 to the power of minus 43 seconds. And that's the earliest we can go back with the engendering of the universe. So we technically have no way of proving by experimental means that there was such a thing as a cause, a primal cause, as in Aristotelian fashion, that allowed the universe to sprout into existence. So I don't know. I know there are critics of that quantum void thing, but I'm not specialized enough in quantum cosmology to comment too much on it.
So, in the view of Bohm, though, you said you're skeptical of idealism. Did Bohm or other people who gravitated more towards Eastern thought, seeing a relationship here, do they have an interpretation of what reality kind of fundamentally is? If it's not all just consciousness, is there a preferred metaphysical system that you do think works?
So Bohm is a complex thinker, because in some parts, so its main book, in which he developed the implicate order and integrated it with the pilot wave interpretation, it's called Wholeness and the Implicate Order. It's a collection of essays published in 1980. And that was later on expanded by Bohm's collaboration with his colleague, Basil Hiley, from Birkbeck College in London. Bohm, if you read it, in some parts of that book, you see that he was a dual aspect monist. So the framework originally thought to have emerged with Spinoza, thinking that mind and matter are different elements that emerge from common origin, but which is neither mind nor matter. It's also referred to as neutral monism by Russell. In other places, you can read Bohm as being an idealist because he does say that somehow the implicate order is closer in his working to consciousness than to matter because of timeless perception of reality that it gives us. So the problem is that Bohm, I think, was only in the very early stages of that model when, unfortunately, he died in 1993. And so other physicists, his friends and colleagues, have been trying to develop that model, but without enough success yet.
Okay. Well, we're coming near the end of our time, but to make it a bit more playful to an end, quantum mechanics is often featured in films, for better or for worse. What does Hollywood get right about quantum mechanics, and what does it get wrong?
So the multiverse, right, of Marvel, which is the main expression, I guess, of that in the popular mind, it's loosely based on the multiverse hypothesis in theoretical physics. The idea that there might be multiple universes out there, maybe an infinite number of them. If you see, so one, I think it was Ant-Man and the Wasp. No, which one was it when he goes to the quantum realm? Was it the third one? Might have been
It's the third one.
The third one. So at the end, you see that he's like there are an infinite number of him moving around at the quantum scale, right? This is completely wrong. Why? Because there is by definition, you cannot measure a superposition of states because it's mathematical. So this is wrong. Like you cannot see that.
Paul Rudd is not infinite. Is okay. Sadly,
can we add this as a fourth interpretation? You got Copenhagen, the Marvel, the many worlds, Bohmian. You know,
perhaps, yeah.
We just need the mathematician to try desperately to make sense of this.
The Feige Marvel interpretation.
It could be very well the case. Yeah. I mean, we're still struggling with it, so why not?
Have you seen this pop up in other movies, quantum physics? I have a best friend who's a doctor, and every time we watch movies where their profession is in it, there's always something wrong that they do in these shows or movies, and I always have to hear about that. Has this ruined Marvel movies and other movies for you?
I mean, ruined, I wouldn't say that because it's still enjoyable to watch. It's still a Marvel movie, you know. And I think I know enough, or at least I think I know enough to be able to distantiate myself from the popular aspect of it and the actual scientific theory. I think it might be a problem when you have people that don't have enough knowledge about that world, because they might be misled in thinking, oh, okay, that's all that quantum mechanics is, you know, like even with the books back in the 1970s, the New Age era, which was really interested in quantum mechanics, somehow proved that consciousness was at the very foundation of reality and so on and so forth. And that impacted many people worldwide. And I think that's problematic because all too often we don't pay enough attention to the way we might be impacting people with what we say from the scientific theories. I think we need to be careful as philosophers and scientists with that.
We're impacting them because everything's entangled, Allan, and nothing exists on its own isolated. We impact and interact and observe because all is one. All hail cosmic Oprah.
You know, I might even say, as a last remark, that so I'm comparing Bohm's interpretation with a particular school of Buddhism known as Huayan in China. And some scholars have made the case that actually it's not just interdependence, it's interpenetration. I'll leave it to that.
Oh, you're going to leave it with that? Most people hear that word and think, oh, that's a naughty word. Okay, I do have one more question for you, which is just as a final sign off. If people are really curious about this, you've raised a lot of really interesting topics and questions. Where would you recommend they go for more resources on this sort of stuff? And where can they find more from you?
So there are two books I would recommend that are very easily accessible. There's no mathematics in them, so you know that's the good thing. One is called What is Real? The Unfinished Quest for the Meaning of Quantum Physics. by David Becker from 2018. It's a really interesting book on the history of quantum physics. The second one is Everything You Thought Was Real About Quantum Physics Is Wrong by Philip Ball from 2018. And this one is more conceptual, explains the intricacies of quantum mechanics, but in a very easy way. So that would be my answer to the first question. About me personally, so if you type my name on Google, Allan Furic, with 2 L's, you're going to find, I think that might be the first result, my profile page on the University of Edinburgh, where I do my PhD. And I'm always happy to answer any question by email that you can find on that website.
Yeah, so you heard it here, people. Google Allan Furic and quantum interpenetration. See what you get.
Don't click images. Thank you so much.
Yeah, no.
Thank you so much, Allan. We really appreciate your time.
Yeah, we do. We appreciate it.
Thank you very much.
We co-taught a class on Eastern spirituality together. And yet every time I talk to someone who's an expert, a real expert on this, I always feel like I'm learning new things.
Yeah, it's just to feel like you know anything about the whole Eastern context, right? Because Eastern isn't a specific thing. Like if you go to this city, that's where the Eastern is. It's so broad. It's India. It's China. And then Tibet is sort of China, but also not. Don't say it's China. And then like it's whole worlds, and it's thousands of years of those worlds. And it's like, I just feel like as soon as I think I know anything about it, I realize how little I know.
Well, and I've had this talk with my students where they give me they're like, yeah, isn't Hinduism X, Y, and Z? And I'm like, well, in my studies of Hinduism, I've realized that Hinduism probably on its own is more broad than the entire Abrahamic faiths, Judaism, Christianity, and Islam. Like 3 faiths together doesn't have nearly as much variety as Hinduism on its own. There's so much variety in it.
Oh yeah, and like I don't understand Islam, and I'm a Christian who reads the Jewish texts, the Jewish scriptures, but I don't even understand Judaism because Judaism is so much broader than what we've dismissively labeled the Old Testament. Like they have way more scriptures than that. So like I don't even understand the religion that I'm kind of co-inheritor of, let alone the entire Eastern context.
So if we thought quantum mechanics was hard, I'm really I'm glad there's people who are doing this, who are relating these 2 facts together. Because it is interesting. You get this sort of stuff in books that are making all these wild claims. It's like, look what quantum mechanics shows, and look how it aligns with X, Y, or Z in some religion that you've only heard about because you saw it on a Discovery Channel documentary once.
Yeah. Well, but even though we might be very diverse and separated by geography and religion, Seth, all of us are entangled at a deeper level. And that's why I think all of the religions are really saying the same thing, because
get out of here.
We are one.
Get out of here.
So
is that what they teach you at Jamestown, John?
That's what I teach at Jamestown, Seth.
Yeah. So let's reduce all religions down to something that makes me feel happy and communal,
And entangled.
And entangled, right? Any differences, they must not be important.
Is the tango, the dance, is that from the word entangled? The tang? Is that like two things?
Well, tango
together?
Is like tangere. It's like the word for like grabbing, right?
Wow, you would know the etymology of tango.
I
guess it, but anyways.
Watch me be wrong. Go ahead.
But yeah, so like this conversation requires so much breadth. It requires you to understand the history of Western science. It requires you to understand Buddhism and nothingness. Like he is attempting to understand something that is almost, it's very difficult.
Well, what's really funny too is he got into other topics like idealism, and I actually just taught this in my philosophy class to the shocked faces of so many of my students who never thought about this before. That everything is just consciousness, that matter isn't what we think it is. Everything is fundamentally the product of a mind. And it's like, what?
Yeah. Well, let me try to give the outline of this both for myself, but also for our audience, perhaps. Like, I think traditionally the religious worldview, at least the Christian one, was matter once wasn't. The first thing in all of existence, the primary thing, was mind, consciousness. God always existed. and then God births matter ex nihilo, out of nothing. So mind is more fundamental than matter. God's mind was here prior to the material universe. But then during the scientific revolution and the Enlightenment, that kind of gets displaced a bit. We begin to see the material world as the primary thing. The material stuff is what really exists. What's fundamental? Atoms. Matter is the most primary thing. And then you begin to see people start to assume that mind is only secondarily derivative from matter, right? Like consciousness didn't exist before matter. Rather, if you give evolution enough time, matter will eventually create consciousness. So they invert the order. Matter is more primary than mind. But and correct me if I'm wrong here, I think the idea is that quantum physics helps reverse that. Some people think that in the spiritual zone. They think that quantum physics is saying that material things don't even fully exist until they're observed or interacted with or measured by some sort of entity. And so therefore mind is resurrected as more primary than the material world, because the material world isn't even solid or localized until mind dubs it so.
Yeah, and the idea that he talked about, like idealism, like he wasn't very big on idealism because it takes an observer, and quite often that is a conscious observer, but it doesn't have to be me who's observing a particle that causes the collapse of this wave function, makes it start acting normal again everywhere at once. Well, he says, there's these non-conscious observers that can also collapse it. So it's not as if consciousness is somehow determining or creating the material world, which is sometimes how this is interpreted. What he's saying is there's just some sort of observation, and that observation doesn't need to be a conscious one. Well, I have friends who are idealists and they use quantum physics and they'll do exactly what you talked about, and they'll say, well, it's because there's God. The reason that we see consciousness can do this and we see it in other places where it's not doing it is because actually consciousness is always doing it, because God is always observing the universe. Yeah. And so they try to use this to create a idealist view of the cosmos.
They basically do what Berkeley did. Like, does a tree exist?
Charles Berkeley?
Yeah. No, Bishop Berkeley. So there's a famous idealist in the late 1700s, Bishop Berkeley, who you've heard his famous quote: "If a tree falls in the woods and nobody hears it, did it happen?" Right? That's ideal.
Did it make a sound?
Does it make a sound? Yeah. And so the idea there is he's saying mind is more primary than matter. And so unless a mind is there to observe it, it doesn't really exist. And so people might say, oh, you're a relativist, Berkeley. And he says, no, for I believe there is an absolute observer who is always observing things, even when individual humans are not. That is God. And so even if a human doesn't observe the tree falling in the woods, God does. And so it happens with or without our consent or observation.
Mm-hmm. Right. So, yeah, you keep saying matter's more primary than mind. I think a lot of Christians are like, well, of course, because God created it. But it's even more extreme than that. It's that there really isn't such a thing as matter as we understand it. Matter is just mind from a different perspective. When I think something is mental, like my thoughts, it's because it's happening up here in my mind. It's private to me. And something is matter if it's objective, if it's out there, if it's public. But what he's saying is in some sense, everything just is thoughts in the mind of God. There is no such thing as a matter outside of mind. Mind is the only real thing, which is so weird because we think of like our imagination is not real. When we talk about that, don't worry, it's just in your mind. It's not real. That's what, you tell your kid whenever they have a nightmare. It's just in your mind. It's not real. And he's reversing that and saying, actually, it's what we think of as matter that's fake. Everything is actually mind.
Yeah. That's so interesting.
Yeah, but he actually didn't agree
he didn't
with
embrace
it.
That. No.
He pointed towards what Bohm, this physicist that he's relying on, which is a different interpretation of what mind and matter is. It's neutral monism, dual aspect monism. Sometimes panpsychism is thrown out there. All complex ways of saying matter and mind are two sides of the same coin. Where one is, there's the other. There's no such thing as matter out there that doesn't have some sort of mental aspect. So even little tiny atoms and fundamental particles have consciousness, a very small consciousness, like way more primitive than anything we could possibly even imagine, but it's still like a tiny shrivel of it is still there.
Yeah, in ways that we might not notice, but are real. Like we have taste buds in our rectum. And I'm not like directly aware of that, but on like a microscopic scale, that's scientifically true. So maybe atoms have consciousness.
Why would you point to that? I've never heard that before, and I wish I'd gone my whole life without having heard that.
It's true, though.
Maybe for you, John. I think that's not true for normal human beings.
No, what's poo for me is poo for you. What?
Oh gosh. Sometimes we do pun battles, but that one was so crap.
It's interesting though. If you say, okay, it's not humans observing it, but it's God observing it, then what space is there for any uncollapsed wave functions in the universe? If God's constantly observing the whole cosmos, then why are there any wave functions that haven't collapsed yet? Shouldn't all wave functions have already collapsed because God's always everywhere observing them?
Oh, I have no idea. I mean, maybe these wave functions are just mathematical, right? Because that would be true of the pilot wave interpretation as well, is that there really is a particle that is determined being guided by a pilot wave. So it seems like it's something that you can probably make sense of. I just don't have the background to possibly make sense of it.
Well, it's interesting that there's some theories that talk about how God, in order to make space for humanity, God literally shrinks to make space for us. Now, I'm not saying that, but what I'm saying is you could imagine some theories that say, yes, God is omniscient in his inherent nature, but he retracts his knowledge in order to make space for us to observe and create and collapse our own wave functions. And so in the same way that Jesus sort of restricts his omniscience in order to be human, perhaps God retracts his omniscience in order to not collapse the wave functions.
That's not Orthodox Christology.
So that we can collapse the wave functions for ourselves and observe and create the universe in our own right. And so God's omniscience retracts in order to make space for us to collapse our own wave functions.
Yeah, you're appealing to it's a God's retraction. It's called Tzimtzum. It's part of Kabbalistic Judaism. Hasidic Jews, if you've ever heard of them, have a version of this idea that God makes space for his creation. He doesn't overwhelm them. There's some sort of retraction on God to allow for the finite. But I mean, there's some theologians like Jürgen Moltmann, who passed away recently, who've tried to incorporate this into Christian theology. It's not super popular though.
Yeah, I mean, you'd be able to maintain still that God is inherently omniscient, but that he chooses to self-limit his omniscience in order to make sense of it.
So he's not omniscient. He's not omniscient.
No, he's inherently omniscient, but he chooses to self-limit, which is
God can become not God.
It's sort of like the best fighter in the world choosing to tie his hands behind his back, and he's no longer the best fighter in the world, but he is still the best fighter in the world. But he's chosen to self-limit.
That's a very different analogy, because what we would want to say is that God just is all-knowing. It's part of who he is to be all-knowing. And for him to be able to self-limit in that way is to say that God can become not God.
Yeah.
Why couldn't he just self-limit to the point that he could, poof out of existence or become just another human being, and therefore, atheism is possible?
So I have a retort, but I think we're getting too far off track here, and we don't need to get into a discussion of how the human and divine natures overlap in Jesus, because that's getting too far away. I think this is an interesting discussion. I'm not saying I agree with it or think Christians should embrace it, but I'm just trying to imagine what one might have to think through in order for God to be omniscient and for the wave function to collapse based on observation and knowledge and measurement of something, and for God not to then collapse all the wave functions. I'm just trying to play these out. Tensions.
Can I shift the topic a little bit?
Do it.
Yeah. So it's funny that I knew a little bit about Bohm and the implicate order because at Durham, my supervisor really pressed me to read his stuff. And that was the one thing I literally said no.
No, I won't. I won't do that.
I won't. It was too difficult. The more I got into it, it's like I don't really have this specialization to talk about this sort of stuff. But I knew enough that I knew like he like had interacted with Judy Krishnamurti and the Theosophical Society and stuff that's come up in other episodes as well. But like, it's funny to me that like this idea that he is going with, this Bohmian mechanics, apparently is having this huge comeback. And also my supervisor, if you're listening to this and you're Christian, my supervisor is a priest, an Anglican priest, as orthodox of a Christian as they come. And yet he thought that there was something to what David Bohm was saying. This isn't just some weird Eastern Buddhist idea. Like, there are Christians, scholarly Christians, who are thinking there's something to this as well.
Can you re-explain the implicate order and what this theory is saying?
Basically, it's this idea that if all particles are entangled from the very beginning, then, like the information is from all points in the universe is somehow contained in every single part of the universe. The whole is contained in the part.
To see the world in a drop of sand and eternity in an hour.
Yeah, in the explicate order. In other words, I don't have access to all the information of the universe. I only have a very limited and, not honestly probably part of the worst part of the universe talking to you right now. And yet there's this other sort of hidden realm, hidden aspect of reality is probably a better language, where all the information is wholly one in every single part. The explicate order only reveals part of that, but the implicate order, you can actually gather all of that at once. So everything is connected in a very deep and intimate manner. Everything is one in this implicate order.
And so this is obviously appropriated at a spiritual level, that we live in the world of duality and a world where we seem finite, limited, not knowing, not omniscient. We're just limited humans who live and die. But at a deeper level, all things are one. Duality is an illusion. We are divine and all-knowing and have access to all of the knowledge.
Well, maybe not divine. And maybe we don't have access to all of it. That would be pushing his ideas too far.
Well, no, I'm saying how it gets appropriated in a spiritual context.
Yeah,
I'm not saying this is true. I'm saying you see how spirituality in the latter 20th century is going to appropriate these ideas and take them to extremes. And it's questionable if they're logical extremes or not, but they're expanding something that is there.
Yeah, and I think if you're a Christian, you don't have to go quite that out there. It's funny that he talked about Buddhism, but the stuff that he talked about Buddhism is none of the stuff that I think Christians necessarily have to disagree with. He talked about the philosophy of Nagarjuna and emptiness and the idea that everything is sort of interconnected. But,
that's Trinitarian.
In some sense it is, right? I mean, Trinitarians would want to say there's also rigid barriers, right? The Son is not the Father, I am not you, but there's also a connection, a deeper unity. If we want to believe that there's a sort of mystical union between us and Christ, that somehow I'm incorporated by some way I can't possibly imagine into the body of Christ himself. Not speaking metaphorically here, that's the language Paul uses. This is at least some scientific stuff that says maybe reality as a whole makes sense of this, or at least it aligns with some of these stranger, kookier ideas that we tend to want to downplay in Paul.
Yeah, no, it's all across. That's even two flesh becoming one in marriage. I mean, these images of union at very practical levels, but also at these higher ontological, metaphysical, theological levels. I mean, that imagery pervades the whole thing.
Yeah,
of unity, difference, but also unity.
And think about this, man. We have a theology that destroys individualism. If you think Adam's sin in some way affects you, there's a connection between you and Adam. That's
an entanglement.
Yeah, I mean, I don't want to use that language. I think that you're just grabbing something from science and applying it to theology when it but you get the connection there. Or if you think there's something between you and Christ, there's an entanglement between you and Christ. Now I'm doing exactly what I just got onto you for.
Because we're entangled.
Yeah,
my mistakes are your mistakes.
We're all one in some sense. Like, we're all one in Christ.
So I was trying to ask him about this. I don't think taking a scientific thing like entanglement and therefore saying everything is entangled at a spiritual level is the right way to go about it. because I don't think that's how unity works in that one-to-one, oh, it's just entanglement. But I wonder if what entanglement shows is that things can be unified in ways that overcome what we think of as difference and distinction. And so it doesn't prove that all things are scientifically entangled, but it does show that perhaps unity can overcome difference in ways that we hadn't anticipated. And so perhaps that's symbolic on a higher level for the overcoming of difference more cosmically. Does that make sense? That's
No.
not saying... No, that's not saying, okay, we've observed entanglement here, therefore we're entangled with God, therefore you and I are entangled spiritually, therefore prayer is entanglement. I'm not saying that. I'm saying, does entanglement show that unity can overcome seeming diversity? Therefore, perhaps unity plays a bigger role in the universe than we thought. Is that too much of a stretch?
Well, yeah, I mean, that's the idea of this implicate order, right? This unity is actually, in one sense at least, more fundamental. And the explicate order is just a sort of outworking of the implicate order. At least that's how I understood it. And so, yeah, this fundamental unity of all things is more fundamental. But what you don't want to say is that we are one with God, unless you somehow think God is made of particles.
Yeah. Well, yeah, I'm not saying that. I think there's kind of two errors that I think we kind of go into here, which is we take one scientific fact and we just expand it to everything everywhere. And we assume that because it's true in one context, therefore it proves everything that we want it to in other contexts. Like, we don't want to do that. And that's what a lot of spirituality and popular spiritual authors have done, is take quantum mechanics and try to use it in contexts where it just doesn't belong. But on the other hand, I do wonder if we sometimes are so trying to avoid that we don't admit, yeah, quantum mechanics does kind of mess with our views of the world and makes it plausible that a whole host of other mysterious things might be the case that we dismissed previously because we assumed the world just didn't work that way.
Yeah, we're still products of the Enlightenment, John. Thanks again for listening to the Spiritually Incorrect podcast. If you like what you heard, don't forget to like and subscribe below, or to check us out on Spotify. And if you want to hear more from this week's episode or guest, our Patreon account has exclusive unaired content, often featuring up to an hour of additional footage and interviews for each episode. We save some of the most controversial and pulse-pounding topics just for our Patreon members. Members get access to that, plus the chance to meet monthly with Jonathan and I, suggest episode topics, join us live for an episode to ask the special guests questions, or even get a personalized episode custom-made just for you. Check out our Patreon link in the description below. And don't forget to check out our official website at spirituallyincorrectpodcast.com to see what else you're missing out on. Sound effects from Zapsplat.com. Special thanks to Jordan Birch, whose song Starry Night provides the intro and outro for this podcast. You can hear more of his music on YouTube or Spotify.